Welcome back to Proving Angles Congruent. This is part 2 of the video. Here we can see Theorem 2.2, the congruent supplements theorem. It states if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. What we're going to do here is prove Theorem 2.2. I'm going to give you or make up a given statement. I'm going to say that angle 1 and angle 3 are supplementary. I'm also going to state that angle 2 and angle 3 are supplementary. We need to prove that angle 1 is congruent to angle 2. This is going to be done in a similar manner to the proof of Theorem 2.1. So by the definition of supplementary angles, the measure of angle 1 plus the measure of angle 3 is equal to 180, and the measure of angle 2 plus the measure of angle 3 is equal to 180. And this right here would be by the definition of supplementary angles, the measure of angle 1 plus the measure of angle 3 is equal to 180. And you can also state that the measure of angle 2 plus the measure of angle 3 is equal to 180. Similar to proving Theorem 2.1, we should recognize that in these two equations that the measures of the angles is equal to 180, or the sum of the measures of the angles is equal to 180. So we'll be replacing the 180 in the first equation with m, the measure of angle 2, plus the measure of angle 3. So using the substitution property of equality, we can make the statement that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. Hopefully you can see the similarities between proving this theorem and the vertical angles theorem. Like proving the vertical angles theorem, you see that the measure of angle 3 is on both sides of the equation, so we can subtract the measure of angle 3 from both sides. So with the subtraction property of equality, we are left with the statement the measure of angle 1 is equal to the measure of angle 2, and then we can say that angle 1 is congruent to angle 2 by the definition of congruence. Here we have to prove that two segments are eventually equal to each other. We need to prove that the measure of WY is equal to that of the measure of Z or XZ. We're going to do that using the segment addition postulate and some properties of equality. The first thing we want to state is this: that we are given that the measure of segment WX is equal to that of the measure of segment YZ. And that by the addition property of equality, we can add the segment that they share, xy, to both sides. So that would give us that WX plus XY is equal to YZ plus XY. Now the segment addition postulate comes in here. The segment addition postulate is going to establish that the measure of WX plus the measure of XY will give us the measure of WY. And that will also go for the measure of XY plus the measure of YZ will give us the measure of XZ. So the segment addition postulate allows us to state that the measure of WX plus the measure of XY is equal to that of the measure of YZ, and that the measure of segment XY plus the measure of segment YZ is equal to that of the measure of XZ. From here we have everything to make our final statement. We established here that WX plus XY is equal to YZ. We established here that WX plus XY is equal to YZ plus XY. Well, what we can do then is substitute 2 times actually. We could substitute the measure of YZ plus the measure of XY in for the measure of WX plus XY, and then we would substitute the measure of XZ in for the measure of XY plus YZ. In fact, we'll just write that out twice. By the substitution property of equality, we can finally say that YZ plus XY is equal to WY. That would be the first substitution. And then we will substitute the XZ in for the YZ plus XY. Now we haven't quite proved our statement because our statement was the measure of WY came first, and that's equal to the measure of XZ. So by the reflexive property we can switch that around. There is proving segments congruent. Here are a few more theorems that you should make note of that will go well with these types of problems. The congruent complements theorem there. If 2 angles are complements of the same angle or of congruent angles, then the 2 angles are congruent. Another theorem, all right angles are congruent. And finally, if 2 angles are congruent and supplementary, then each is a right angle. Hey, thanks for watching. I hope this video helped you. Feel free to leave a comment or rate the video.